Hi, Chem students. For lab this upcoming week, we'll be using computational quantum mechanics software called Spartan Student Edition. And this particular piece of software allows you to put in what you think a molecule looks like, have it do some really high level calculations, and with those calculations, it'll estimate real bond lengths and real bond angles, the energies of molecules, and some other fascinating things that you'll learn about if you stay a chemistry major and use this software over time. For now, I just want to show you a few tips and tricks on how to use it so that when you come in and play with it, it'll be fairly simple. And they've really made this easy to use compared to the old days when you had to type in coordinates for everything, and it was a real mess back then. So I hope you enjoy learning to use Spartan Student Edition. Okay, so up here in this top left corner, you'll see the little water molecule that's allowed you to build a new molecule. And if you go over here to the right, there's a palette that pops up. It allows you to choose lots of things. You can choose some very commonly used organic, because we're in the organic menu, orientations and electronic geometries and molecular geometries of species right here. They even label them with hybridization. So this one's labeled as a CsP3 because that's a carbon with an sp3 hybrid orbitals. 4 hybrid orbitals. Here's phosphorus with sp3 1 2 3. The other ones that got a lone pair on it. So we can choose and make most of our molecules right here. There will be times when you have to go and make what you want from the periodic table. You'd go here and click and choose what you'd like to play with, and that's how you would build inorganic. And as you get to higher level chemistry, you might make peptides and nucleotides and do some, play around with some rings like benzene and such like that. But for now, we're going to do very simple molecules to get the hang of it. That being said, let's go ahead and make a real simple molecule. Let's make just methane. And I click on the center, and you see that you end up with a carbon with 4 little spokes coming off of it, of which you can put anything on that will single bond. And I'm rotating it in space by left clicking and rotating. If you right click and you can make it move around and translate, you can make it move around and translate if you do that right there. Right. And you can also make, if you scroll, you can make these larger. You can make them larger and smaller so that they take up more space. For now, I'll give you a little hint about some of the things. These 4 bonds that are there, currently there's nothing attached to them. If you want to just make methane, which is CH4, then each one of those would have a hydrogen on the end. Anytime you leave one of these blank, Spartan's going to assume that it's a hydrogen. So we can quickly get to methane by just clicking right there, and you see now it's put 4 hydrogens on there, and we can now play around with this tetrahedral, and we could do a calculation on it with ease if we wanted to. Let's go ahead and build another molecule, something a little more complex. And I can leave this one just as it is, and it'll create a tab down here at the bottom left that we can play with. So as you see, when we make our next one, here's our tabs. I guess it's not the bottom left in this particular version, but here we go. I can make something like, I can make a phosphorus compound that has 2 hydrogens and a chlorine by attaching a chlorine onto the end, and the other 2 are going to be automatically going to be hydrogens. And voila, there I have this weird molecule, this chlorine mess, whatever it is. I don't know what this thing is. And I'm just, of course, spinning it around because I can. Let's go ahead and do a calculation real quick because that's really what you want to learn how to do. So we're going to do just our friendly neighborhood water. It's an easy one to do. It's got an oxygen and 2 hydrogens on it. Right there it is. And now that we're at the point where we've got the molecule we want to play with, we can go ahead and create a calculation. The calculation is we have to go up here to the setup menu to do so. And when we click on the setup menu, it immediately says calculations. Now, what we're normally going to want to do is do an equilibrium geometry optimization. This allows the molecule to be adjusted with bond lengths and bond angles to get to the lowest possible energy. There are other options in here, like just getting an energy, which will take the current drawing of the molecule and find the energy of that particular state, and some other things you can do if you really get into it. Then, whenever you do this calculation, you must choose the methodology of the mathematics. So There are different ways to try to solve the quantum mechanical problem, and Hartree-Fock is one method. There's two density functional theories. One's called Becky 3-Lip, the Becky 3-LYP, and the EDF2. Both of those are density functional. And then there's also one called MP2, Moeller-Plesset theory. It's second order perturbation theory. So just different ways to do the math. As you go down, they tend to take a little bit longer in time to get finished. And then what we're doing calculations on is electrons and orbitals, but we really don't know what the orbitals are. So what we do is we have some really good sophisticated guesses, and they're given these systematic names based upon how they were built. There's a 3-21G. So this one's built, all of them that we'll be playing with will be built upon that Gaussian function. And then this just tells us how we're doing things. It's called a split valence. Not important for this class. So we could choose one of these guys. I can do a 6-31G star and a B3LYP calculation. This is a neutral molecule, and if I draw the Lewis structure, which I need to do, there are no unpaired electrons. We always have to put this in. I can ask it for other things. Can I see the infrared spectra, the vibrational modes, NMR spectra? All these things are worth looking at different times. But the more you click, the longer your calculation takes. But these won't take very long at all. When you're ready to run your calculation, you're going to be tempted to press OK. That's fine. What that does is just stores this as a calculation you want to do. What you really want to do is submit it. That'll ask you to save it, and then it will run the calculation for you. So as you see, this guy is going to come up and say, where would you like to do this? And I'll just put it right here, water.spartan, and then I'm going to hit save. And it says, hey, you've submitted the job. And very soon now, in a matter of seconds, it will come back and say, this job is complete. And that's how you know when you've finished, like this. So now that you know that it's finished, you can now play around with what the outcomes are of the calculation. So there's the same molecule. We can go up here to display now, and we can look at the properties. And as you see, I'll move this over to the side. It gives us a whole bunch of properties. The name, if it knows it, the formula, the atomic mass, or the molecular mass, I'm sorry, the volume that this molecule takes up, and then the surface area of the molecule. Here's something called the point group. You don't need to know about that. But here's an important piece of information. It's the energy. And it's given in AU's atomic units. It also estimates the enthalpy of formation of this stuff in the gas phase. So this is an estimate from the calculation, minus 237.59 kilojoules per mole. And right there, it knows what the literature value is. This is what the experimental value is. So not a bad estimate for calculation. You can also check out the dipole moment and see where it lies in a molecule and when you make it and do the calculation here. So the properties are done. There's other options to see what's going on. If we go to the display, we can look at the output. And the output, even though this is small, I don't know how to make the writing larger, you can scroll down to the bottom and see some different things about this. So here it tells us the energy calculations. If you ask it to print out the some aspects of those options you can click, you'll get more information here, such as you might end up finding out what the entropy is or what the Gibbs free energy is. There's also ways of obtaining that, which you'll be using in your directions by clicking on this spreadsheet button. And when you're here, you're able to input and add what you want to find, and Spartan will go and grab it and put it in here and let you know what that is. So you'll be using the spreadsheet function in your upcoming experiment on thermodynamics. All right, so that's how you run a calculation. You go up to the setup, you hit calculation, you fill in the appropriate theory and basis set. That's the type of orbitals you want to use. And when it's done, you try to look at the data and see what it tells you.